Hi everyone, welcome back. So Codeforces question for today is Olya and Game with arrays. So our team suggested a game to the girl Olya. There is a list of n arrays where ith array contains mi, which is always greater than equal to 2 positive integers. Olya can move at most one integer from each array to another array. Note that integers can be moved from one array only once, but integers can be added to one array multiple times. All the movements are done at the same time. So the beauty of the list of arrays is defined as sum of minimum of each array. In other words, for each array we find the minimum value in it and then sum of these values. The goal is to maximize the beauty of the list of arrays. Help Olya win this challenging game. So this is the question. We have an arrays in which each array will have mi elements, and we have to find the sum of minimum elements of each array. This operation we can do for each array. We can remove one element and move it to another array. So this is the operation that we can do, and we have to maximize our sum. So how shall we do this? So when we see this question, we have to do the sum of minimum elements, right? So the trick in this question, the first thing that we can know is the minimum element among all the elements. Wherever it is there, the minimum element of all the lists, all the elements, that element will definitely be in the answer, in the sum, because wherever you place it, it will remain the minimum because it is the least element. Now for all the other arrays, we can remove their minimum element and place it somewhere else, right? So their second minimum, we can remove their minimum element and place it with the minimum element, right? So that all of them will be having the second minimum as their minimum, because we have removed their minimum elements and placed it with the least element. So they all will be having second minimum as their minimum, right? So this will maximize our sum, but still one element is more there, because for the minimum element also there will be second minimum, right? So we know that minimum element will always be there. We know that we will have second minimum of all the arrays in the sum. One element is extra. Which one should be removed, right? Because n lists will have n digits minimum for the sum. So the second minimum, which is the least second minimum element, we can remove that because we cannot remove the minimum. All the remaining second minimums we will take, and the least second minimum we shall remove. So this was the trick in this question. How shall we do this? We shall take three test cases. For each test case we will take n, that is the number of arrays. We shall have minimum and second minimum. We have kept them to max values, and the sum of all the second minimums that we will keep in our variable sum is equal to 0. Now we put a loop from 1 to n. For each array list we take m, that is the length of that array. We take a array list, add all the m values, now sort it. After sorting, minimum will be at 0th index and second minimum will be at the first index. So we calculate our minimum element by comparing it with the minimum value, and least second minimum we shall have a smaller second minimum in asmin by comparing with the second minimum values, and in sum we will add all the second minimums. So we have got sum of all the second minimums, we have got our minimum, and we have got our minimum element of the second minimums. So now what we had to do, we had to add minimum to our sum and remove the second minimum, because we will keep our minimum in the array which will have the least second minimum, so that our least second minimum is removed with min, and rest all the other arrays we will have the second minimum. So this is the maximum beauty of the array. This was the trick in this question. I hope you guys would have got the idea. Thanks for watching the video. Have fun. Bye.